Hi everyone, my name is Ishwafani Parchuri, and this is a project on time series analysis which is collectively done by me and my friends, namely Gururaja Gosala and Sujay Kamal Madsetti. So, before introducing this topic to you, what here we are trying to do is we are trying to analyze the data, explore the data, do some visualizations, and based on these visualizations, we are trying to predict the future. So, in order to do this, the dataset we chose for this project is a COVID-19 dataset, and it is a COVID-19 dataset from the country India. And this data set contains two columns with one for the date and the other with the number of cases. So this data is recorded from the 30th of January to 25th of May, which is the start of this week, 83 days to be precise. The goal of this analysis is to predict the chances of the increase or decrease of the cases in India for the coming 10 days from the 25th of May. So this data set was initially in data frame format. We changed it to time series format, and we plotted the time series graph as you can see on your right, and the ACF and PACF plots for the same COVID-19 cases in India. From the analysis, it is pretty much clear that there is an increasing trend in the series. Now going forward, upon doing the further analysis, we try to fit this data to the linear and quadratic models, and this graph shows that the models being fitted exactly into the data. However, the linear seems to be comparatively odd, and the quadratic seems to be the perfect fit for this model. From the summary statistics of quadratic fitting, it is pretty much clear that 97.19% of data fits the quadratic model, and there is very negligible difference between the multiple r squared and adjusted r squared values. The quadratic model looks better fit compared to the linear model, but this still can be early to decide these models. Why? Because as it is pretty much clear that this data shows an increase in trend, and also as the number of cases are increasing on a daily basis, there is a chance that the mean may also be varying daily, and it is increasing daily with respect to the data. Now, since we could pretty much easily say from the initial ACF and PACF plots that this data has a definite increasing trend, in order to detrend and analyze the data, we do differencing. And in order to make sure that our approach is more viable and reliable, we did the augmented Dickey-Fuller test, which also supported our decision that differencing is the correct approach, as initially we got the p-value to be 0.99, stating that this data is not stationary. So upon a degree 1 differencing is done to analyze this data, and upon doing the degree 1 differencing, the augmented Dickey-Fuller test is done again, and now the p-value is very negligible and is less than 0.05, stating us that the alternative hypothesis that this data is now stationary. Now the p-value is less than 0.05, and the series appears stationary after the first differencing, and ACF and PACF plot are also adding support to our hypothesis. That being said, now we need to make sure which is a better ARIMA model fitting to estimate and give the forecast for the coming 10 days. So as in ARIMA, AR stands for auto regression, I stands for integration, and MS stands for moving average modeling. And P is used to determine the AR, and D is used to determine the integration, and MA is used to determine, and Q is used to determine the MA. So these variables stand for our ARIMA models. And since we already did one level of differencing, our D value at the moment is 1. And EACF table and BIC table have been plotted. And let's analyze the EACF table, and it's pretty much clear from the EACF table that 0, 1, 1, 0, 1, 2, and 0, 1, 3 seem to be most viable model approaches. As we increase going ahead, there is a chance that our error may increase as well. And also from the big table, 114 and 116 seems to be our best chosen models. Now, upon doing the residual analysis and understanding which model stands better, we came up at a conclusion that ARIMA 0, 1, 2 seemed to be the best fit for the model, as the histogram shows a bell curve with the normally distribution and skewed towards the tail, and the ACF plot looks stationary with no seasonality, and this is how the trend and moving average is going is. And now coming to forecast, the series started at a pretty low rate, but there is a steady upward trend in this time series. There is a strange upward pattern, and there is an increase in the number of cases over the coming 10 days as well. After doing the forecasting using ARIMA 0, 1, 2, this is how the plot for the forecast is, and this is how the 95% confidence intervals are, with the mean lying here. And the forecast, the point forecast exactly show that there is a definite increase in the cases of COVID-19 for the coming 10 days in India. And this is how the point forecast varies. As I remember, the last value, 25th of May, is somewhere around 6,900. And from 26th of May to 4th or 5th of June, this is how the point forecast is going to be. And this is how the 95% high and low intervals are going to vary for India in the coming 10 days. The number of cases of COVID-19 is going to increase day by day rapidly from 26th of May to the first week of June. And thank you for giving us a chance to explain our time series analysis and to do the forecast on real world data. And I'm extremely happy that this helped us to analyze how the future is going to be for a country like India, that too in a crisis like COVID-19. Thank you everyone.